Hi friends, welcome to my channel. Let's have a look at problem 40, combination sum 2. This problem actually is related to the daily challenge problem for today, that is combination sum 4. So we'll do this problem 40 here first. So in this video, we are going to share a solution based on backtracking or traversal solution. So this problem gives an array called candidates and a target number called target. So we are required to find all unique combinations where the candidate numbers sum to target. So each number in candidates may only be used once in the combination. Also, the solution set must not contain duplicate combinations. So here are two examples. Before we look at the examples, let's look at the constraints. So first, the length of the candidates array is bounded above by 100. And the second one is important. So the candidates has a lower bound, that is, the candidates range, element range, has a lower bound, that is 1. In other words, every element in the target in the candidates array is bounded above by 1. So the target is in between 1 and 30. So with that said, so let's look at example 1. So in example 1, so there are 4 combinations listed here. Actually, for this problem, so essentially we are using sort of a brute force solution. So we are going to check or build the combinations. For each number, we decide if we include it or not in the combination. So we are going to use using a sort to slightly accelerate the build process. So this build process corresponds to the backtracking. So here is an example corresponding to example 1. So if we sort the array, so we have 1, 1, 2, 5, 6, 7, 10. And then we have these 4 numbers. So actually after the sort, so we are easy. It's easy for us to write stop conditions. So here, because of the nature of this problem, let's directly go to the code and then we analyze the details. So first, I changed the candidates array name to a capital letter A for convenience of writing. So with that said, let's split this into 3 steps. First is some initialization and preparation. So here, first, I'm going to sort this A in place. So this way, it's easy for us to do some pruning or early stopping. So next is that we're going to initialize a answer variable. So during the process of building each of the combinations, we are going to add them to the answer list, and finally we return the final state of the answer list. So we're going to use a path variable to aid the build process or the backtracking. So I'll include this variable path in the second part, that is the backtracking or traversal. So this path will be a reference. So I'm going to define this function. Let's call it f. So we can call it DFS, or we can call it backtracking. So it accepts 2 arguments. One is the index, so which index currently we are looking at, and the total. So the total number, the sum we built is called total. If the total equals target, so that's we achieved 1 combination, right? Otherwise, we continue the process. So as its routine, let's first write some stop conditions. So if total is strictly larger than target, so in this case, we are going to return, so without doing anything. Otherwise, is if total equals target. So in this case, we are going to update the answer array and then return. So in this way, we are going to append a copy of the path, current state of the path. So here, the copy is important because we are going to continue or do recursive call using the path state. So after we add this to the answer, we're going to return. So this is the return conditions. So next, we are going to do the recursion call. So notice that So each number in candidate may only be used once in the combination. So this is an important condition. So in order to take into consideration for that part, we're going to introduce a variable called previous, so which we can set to be -1. So actually here any number less or equal than 0 will be good. So the reason is that in the assumption or constraint, we know AI is greater or equal than 1, right? So we can choose 0 or -1. So for our comparison below. So then we are going to do a for loop for I in range idx ending at the length of the candidates array. Then because we are not allowed to use the same exact element for twice, so we are going to check if AI equals previous, then we are going to continue, right? So then if this is not the case, so the current number we are seeing is not the exact same number as same element as before, then we're going to append the path, the current number, and then continue the building process, that is f move to the next index and total plus AI corresponding to choosing this AI, right? So if we do not want to choose this AI, we can do this. We're going to pop this current added one, and then we set the previous to be AI. Then next time we see same exact element, we're going to ignore. So that's the backtracking on function or the worker. So we can think of this function as a worker, right? So once he or she builds a valid combination, she will add this combination to the answer container. And once we call this function, so it will update the state of the answer. So with that said, I guess now we are ready to do the return. So we first call this function. We are going to start from index 0, and the total number is also 0 at the very beginning. Once we call this function, it will automatically update this answer container. And then what we need to do is just return the final state of the answer container. So with that said, I guess that's one full solution for this specific problem. So first, let's do a special case check. Yeah, it passes a special case. So now let's do a generic case check. Yeah, it passes the generic case. I guess that's a solution for this problem. So actually we feel that, so when we use the backtracking, basically the paradigm or the pattern are sort of routine. So first we get some stop conditions, and then we do the recursion call, and in between we update the state of the path. So a point which deserves some attention is that, so here when we append the prepared combination to the answer container, what we appended is actually a copy of a path state. So that's actually crucial. So with that said, actually you can come back to see the problem or example here, right? So if we choose this one, then we get 1, and then we continue the build, we have number 2, and then we look at these numbers. If we check 6, so 1 plus 6 is 8, so we get 1 combination, right? So then you can do a recursive analysis for this example. So with that said, I guess that's about it for this problem. Thank you very much.